Okay, so we have Lauren and Ankita live here to help answer all of those great questions. We had some great
Hi.
feedback come through from the audience there. We've got some awesome feedback around the use of Australian data in the Victorian analysis, so thank you for that. And
Of
the
course.
some of the questions have come through. There's quite a few of those, so we've got a good amount of time here to get through them, but I better jump straight in. The first one is for you there, Lauren. The emerging hotspot analysis that presented COVID hotspots over time in 3D was something that really caught my eye. What's your advice on the best way to share data like this with executives or decision makers?
So this is a great question. Actually, we have like a whole workshop dedicated to kind of thinking through some of this and thinking through, how do we think about visualization from an analysis perspective, and um, how do we focus on the difference between what I need as an analyst and what a decision maker needs to use the results of my analysis. And they're not really necessarily the same thing. So I think with emerging hotspot analysis, it's kind of set up already in a way that we are trying to help you interpret the results of the analysis. We take this beautiful 3D map, which by itself, while beautiful, is not necessarily all that useful. Um, and we boil it down to those categories. And so the categories help you interpret that 3D map. And it means, okay, now instead of looking at just hundreds of thousands of bins in 3D, I can actually say, okay, I want to look specifically at this location and what's been going on over time at this location. That just is a lot more interpretable. Now, when it comes to a decision maker, they may not even need the 3D at all, though we can certainly publish it as a web scene and share it online through things like story maps. And we've got lots of examples where we do just that as kind of the evidence behind a recommendation we might make. But what we've found is that with decision makers, the most important thing is to think through like, okay, so we have these categories that we create and give you the results of. Um, do you actually need all of those categories for a decision maker? Does a decision maker care about the hot spots and the cold spots, or maybe they just care about the hot spots, depending on what the problem is that you're trying to solve? And so you can get rid of a bunch of categories, simplify your map. Maybe you can even group together a couple of categories that aren't as meaningful to the decision maker. So I think it's really important as an analyst to take off your hat of like, I want all of the data, all the information, everything there is to know, and say, okay, well, what does a decision maker actually need to make their decision? And try to simplify that information as much as possible, and tell a really effective story. I think that I've seen some really interesting conversations about what's a data scientist and what's a spatial data scientist. And I think one of the things that makes the best spatial data scientists is being a great storyteller, because it doesn't matter how great your analysis is, if no one can use it to make a decision, then it's not very useful,
And it's not useful. Yeah,
No.
that's a great answer. Thank you. The next one is Ankita there. So what are your tips and tricks for processing large volumes of space-time data?
That's a really interesting question, because like now everyone is getting their data, so the data is just becoming more and more and is getting available to everyone. So it's like very important to be able to kind of optimize your analysis to do a better job with this big data and large volumes of data. So within ArcGIS Pro, we have this option in the environment settings of these spacetime tools, called parallel processing factor. So you can choose to specify how many processors on your machine you want to fire up to do the analysis. Let's say you have 16 core machine and you want to dedicate 50% of your processors for analysis to speed things up. And if you are in ArcGIS Enterprise, we have GeoAnalytics Server to process and analyze big data using distributed computing framework. And now many of the GeoAnalytics Server tools are available in ArcGIS Pro as GeoAnalytic desktop application and desktop tools, which provide that similar parallel processing framework on your desktop machine using Apache Spark. So really depending on where you are performing your analysis, is it on your local machine or is it on server? There are these ways to optimize processing of large volumes of data.
Yeah, to really reduce that time. That's another great answer there. So, what I guess, and I've experienced that myself as well when I can, add as many resources to from my machine as possible to really ramp up that processing time. And I guess one of the things I normally would have looked to if I couldn't really get the time within a frame that I wanted would be I'd start to look at, say, geoanalytics server on say, maybe a cloud infrastructure. And I mentioned this before, in Australia, two of the most common cloud infrastructures are Amazon Web Services and Microsoft Azure. Are they, just out of curiosity from my end, is that something that you've leveraged to speed up this type of processing?
We have, I will say specifically for the spacetime cubes, and creating spacetime cubes specifically, it's actually really, really fast. We create those spacetime cubes as netcdf files, and they are incredibly optimized for dealing with spatiotemporal data. I would say we're more likely to move to geoanalytics for pretty much any other kind of big data processing. So lots of stuff with movement, really, really cool movement tools coming out of the geoanalytics team, which are really exciting, and having them in Pro is really powerful. Also, a lot of spatial statistics tools, density-based clustering, which is hugely optimized when it's distributed for massive data. They also incorporate time in a really powerful way in geoanalytics. So I think that being able to do that kind of cloud distributed computing for massive data is especially important when you're doing pattern analysis and spatial statistics, and we definitely do take advantage of geoanalytics for that pretty regularly. It just so happens that the spacetime cube is this like amazing format that works pretty efficiently on pretty large data, even on your desktop.
Oh, great. That's great to hear. Actually, the netcdf data format, that's come up quite a bit here in Australia with some of our users from some of the departments like the Bureau of Meteorology, even Geoscience Australia, one that I work quite closely with. How would you, I know there's been some advancements in Arcgis Pro and how you work with netcdf. Are you able to talk about some of those?
I think what I would mention is the voxel layer, which just came out in this last release, and is this really powerful way of visualizing netcdf data, multidimensional data in general, but definitely specifically netcdf data. It's a great format for, and it's this, if you haven't seen the voxel layer in action, I would definitely check it out, because it's just stunningly beautiful to watch how you can manipulate and explore this multidimensional data inside of ArcGIS Pro. And that also supports spacetime cubes. So we were kind of a stakeholder on that project, because we wanted to make sure we could take advantage of this new technology for spacetime cubes and our users of spacetime cubes, and we certainly can. So actually there's a recent Learn lesson on using voxel layers and spacetime cubes to analyze social distancing data that one of our colleagues, Ting Wan, worked on with another colleague, Phil Milkey, which is pretty cool and worth checking out also. But those voxel layers in general are amazing.
Okay, thank you. A great answer. So there's a few more to get through there. I want to try and get onto a couple of those. So this next one is probably to either of you, whoever prefers. There's a lot of different clustering techniques. How do I decide which one to choose?
So I'm sure Ankita and I would give different answers, and I'm curious about Ankita's perspective. I mean, to me, it's like there's statistics and there's machine learning, and there are these different approaches. And the most important thing is to think about your question. You know, it's not about what method you're going to use. It's about what question you're trying to answer. I think it's too easy these days to, it's like human nature. There's these shiny new algorithms and approaches that we want to try. and it can be easy to get swept away by
Caught up.
the new and the exciting, and that doesn't necessarily make it the best method to use for the problem that you're trying to solve. And so I'm a big proponent of starting from the place of your question. I don't know if you have anything to add, Ankita.
Yeah, absolutely. I was just going to say the same thing, that like people think this machine learning and artificial intelligence, but like we have all this. But if your question is to find these like clusters of traffic clusters and traffic patterns, which easily like density-based clustering can solve, like why would you go to an algorithm called random forest? So it's just exactly what Lauren just mentioned, that it depends on the question that you're asking. So there are like different types of clustering algorithms that I think Lauren mentioned in the presentation, like supervised and unsupervised clustering. So it really boils down to what your question is and what you're trying to answer using these clustering tools.
Okay, thank you. So start with the why, then you can pick which option to use. Alrighty, thank you. So the next one, and this is probably, let's start with Ankita for this one, and then I think Lauren will also have a view. So can you give us a sneak peek at what's to come in this space, or maybe a bit of a look at the roadmap?
Yeah, so like our team is working on a very exciting data engineering project. So basically, like whenever we start doing analysis, the biggest pain point is just to get the data in the right format, and just to like clean up your data, fill missing values. Like if you are doing regression analysis, you want to transform your field into do a standardization. These little parts of just getting your data to the point where it's ready for analysis has been a great pain point. I think 80% of an analyst's time is just spent on getting their data ready for analysis. And that's what we are working on, to kind of reduce those pain points and provide that capability in Arcgis Pro, so that that workflow could be streamlined and could be like we can provide more options to investigate your data, to kind of see what you can do in your data to make it analysis ready. So this data engineering project that I'm like really excited about, and our team has been working on, is something that we are hopeful that would be very helpful to our users. And Lauren, do you want to add something to that?
Yeah, I mean, I think Ankita's one of the key product engineers working on the data engineering project, and it probably is the first thing I would have mentioned also. Because I think it rounds out when we think about what's data now, what's spatial analysis, data engineering is a key piece of it. And we have, we all do our data engineering in ArcGIS already, but this is really about streamlining it, and we're really excited about that. I would say there's a bunch of other projects going on. There's a lot more work going on in the area of thinking about time series analysis. So there's a lot more time series, thinking about outliers, both time series outliers and spatial outliers. We've got some work that we're doing looking at comparing two categorical maps that we're really excited about. That is definitely filling a hole that I know a lot of folks are going to be eager to use these tools to do. So yeah, this is actually a huge release for us, and I think that like this coming release that we're working on, and some of the things we've got kind of in the longer term plans, spatial data science is one of the core capabilities of ArcGIS, and we're busy making sure that it's everything you need it to be, basically.
Okay, well, thanks, Lauren, and thanks, Ankita. That was a great answers. We've had one come through from the audience, and this is definitely one for Lauren there. When are you coming back to Australia?
I would love to come back. I was supposed to come back this year, actually, and then obviously the world took a turn. But I'd love to come back sometime soon. I know, although this time I'll have to travel with Ankita because I know she would love to come with me, and we'd love to see Australia together, talking about
That
spatial
would be great.
stats.
Well, we would love to have you here,
Absolutely.
that's for sure. I know the team has missed you. So we've only got time for one more question, and this one's over to Ankita. What's the best way to learn about these methods and really start to use these in my own analysis?
That's a great question, and we do have a ton of resources. But the first thing that comes to my mind, and the first thing that I usually do when I want to learn more about a new tool, is the tool documentation itself. Like, believe it or not, we put our heart and soul into making the tool documentation as informative and as transparent as possible, so that when our users use our tools, it doesn't feel like a black box. So we do put information regarding the algorithms that run under the hood. We also provide some gotchas and some best practices to use these tools so that you can use them for your analysis. And another resource that comes to my mind are the blog posts. So for instance, all the time series forecasting tools that I showed today, we have a series of 4 blog posts written by very talented product engineers on our team with some real world examples, so that you can look at how these tools are used in real world, and you can apply that in your analysis. Also, learn lessons are a great way to get started. So if you go to learn.arcgis.com, you'll find a lot of great learn lessons and resources. And as I was just going to reiterate what Lauren mentioned in the last presentation, that if you want to learn more about spatial stats, then we have esriurl.com/spatial stats with a lot of workshops and examples that you can follow and really get started with your analysis. And also the spatial data science MOOC. So I highly encourage everyone to kind of just enroll and get started with it. So there are
It's
tons
true.
of
I mean,
resources.
this presentation was 25 minutes. We would have. It's like, are you sure we can't have 10 of them? I mean, we could have talked for a lot more than 25 minutes about this.
Well, thank you very much. That was a great answer. There are a lot of resources to get started there, especially ones that are openly available for everybody. So I really appreciate those wonderful answers. We're coming to an end there. So I've got to thank you very much, Lauren and Ankita, for joining us today. It was an absolute privilege to meet you face to face and work with you. And thanks again.
Thanks for having us.
Thank you so much. Yeah.